Kia ora, I'm Weka. Here's the second video going through the JAF measurement practice, or as it says here, measurement practice. So in this one, I'm going to do the rest of the unistructural questions from question 8 through to question 16, and I'm going to crank up the pace just a little bit. So here's the next question. We're given a diagram of a car race, and we're told that the race is 10 laps of the circuit. So we've got to read the question carefully because we actually don't need that information about 10 laps at all. So to the nearest kilometre, how far does the car travel if it does one lap? And then how far does it travel if it crashes at point B on its second lap? Okay, so let's first of all see how far it goes if it does one lap. Well, it goes here, 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 and here. And so if we add those lengths up, we get 2.5 plus 1.7 plus 0.75 plus 2.15. And if we chuck all of that into our calculator, we get 7.1 kilometres. But we were asked to give our answer to the nearest kilometre. So it's 7 kilometres to the nearest kilometre. Okay, and that's the sign we can use for roughly equal to. Okay, now if it crashes at B on its second lap, let's see how much further it goes. So it does 1 full kilometre, and then it also goes back to the start, and then it goes here, and then here, and then here. So what do I have to do? Well, I have to take 7.1 kilometres, so my exact answer there, and then I add on those three bits. So 2.5 plus 1.7 plus 0.75, and that gives me how many kilometres? Let's have, I think it's 12 point something, I think. 12.05 or 0.5 kilometres. So to the nearest kilometre, that is 12k. So what we're getting you to do here, and this is just to make sure that you can read a diagram and link up the text over here. The text over here, where's my pen gone? With the diagram over here, and put those two together. Okay, on to question 9. Now this is one where we're given a timetable, and it's the same kind of thing. We want to see if you understand how to link up the words with the information in here. So it's a ferry timetable between Wellington and Picton, and it's just the part showing the ferries going from Wellington. So how many sailings are there from Wellington on Wednesday? So we go through here and we look and we find the Wednesday column, and we see that there are 3 of them. Okay, so the first one, the answer is going to be 3. Now, when or what time does the earliest sailing leave Wellington on a Thursday? So we need the Thursday column, and the first one to leave is at 9 a.m. The trip from Wellington to Picton takes 2 hours and 55 minutes. At what time does the 4:30 p.m. sailing arrive in Picton? So most of you can probably do that in your head if you think about what 2 hours and 55 is. That's just 5 minutes short of 3 hours. But again, if you want to do a number line, that's a good way to make sure that you're getting it right. So 4:30 plus 3 hours will get me to 7:30, and then I want to go back 5 minutes, right? So that gets me to 7:25 p.m. Or if you're not comfortable doing the going backwards thing, you can go forwards 2 hours to 6:30, and then another half hour will get you to 7 o'clock. So that's plus 30 minutes. And then you've got 25 more minutes left, and that gets you 7:25 p.m. Right, the last one is checking that you're comfortable with doing 24-hour clock time. We actually didn't do this in class, but we'll do it now. So 8:40 p.m. is going to be, p.m. means in the evening or in the afternoon. So the 24-hour clock starts at midnight at 00:00. There are no decimals or points in there. And so then 12 o'clock noon will be 1200. So 8:40 p.m. is 8 hours on from that. So it's going to be 20:40 is how we write it, right? So it's not this. It's not 20:40 p.m. That's kind of a weird mix of the two systems. If we're doing 24-hour clock, we want to write it with no decimals, no colons, no AM or PM, just 4 digits. Okay, right, on to question 10. Right, find the volume of this prism, also known as a cuboid. So let's go back to that formula sheet we had in the first video, and we saw that the volume of a prism is this one here. It's the cross-sectional area times the depth. And so in this case, the cross-sectional area Well, it doesn't matter which pair we choose because it's a cuboid, but we could do the front face here first, and then we're going to multiply by 25. But the other way that most of you will do this one is to go, oh, volume of a cuboid is length times width times height. Either of those approaches works out fine. Okay, so it's going to be 60 times 10 times 25, and the unit will be millimeters cubed. So when we put that together, we get 600 times 25, which is 150,000 millimeters cubed, I think. Let me just check that. So I'm going to check it without a calculator. If it were, so it's going to be 600 times 100 divided by 4. So let's see how many zeros I get. 1, 2, 3, 4 over 4. Yep. So I think something's gone wrong with that. I don't think it is 150,000 millimeters cubed, is it? It is 115,000 millimeters cubed. Okay, for those of you who haven't given up on me, I just want to make it really clear that this answer is wrong, right? It's not that. So how can I check? Well, I'm checking in several different ways. I'm using my number sense, right? And 60 times 10 gives me 600. 600 times 2 would give me 1200. So 600 times 2.5 would give me 1500. And that means that 600 times 25 is going to give me 15,000. So it's 15,000 millimeters cubed. Right, sorry about that. I think the printed answers to that one might be wrong. So just have a check. Okay, all you got to do is times the three numbers together. On to question 11. This one's just looking at which measurement, which unit is the best one for each of these things. So the length of your hand, we're going to want one of the units that measures length. So we're going to be choosing from these ones: millimeters, centimeters, meters, kilometers, and the rest of them don't measure length. The length of your hand, the appropriate one to pick here is centimeters. Okay, so the first one's centimeters. Now, the mass of a cup of flour. Well, we're going to choose from this one: milligrams, grams, and kilograms. So that one is going to be best measured in grams. The amount of water used by a household in a week. So we're looking here at liquid volume, which is milliliters or liters. So the best unit there will be a litre. If you think about how much water you fill up a bath with or use in the shower or use to do the dishes, you definitely wouldn't be measuring it in milliliters. So milliliters I think of as if you're taking Pamel when you're a little kid, that's what we measure in milliliters, right? So small amounts of medicine. Last one, the mass pulled by a locomotive on a train, which is a fancy way of saying how much weight can a train pull behind it. So again, we're going to be looking at choosing one of these units here. So it'll be grams, kilograms, or tons, and it's the last one here, T. Okay, so T for a ton. So that's 1,000 kilograms. Right, on to question 12. So we're starting to get slightly more involved, but still should be feeling pretty good. A runner wants to run 10 kilometres. How many laps of a 400-metre track does he have to run? So here's the track, 400 metres, and he wants to get up to 10 kilometres. The first thing to do is to put those two things into the same unit. So the track is 0.4 metres long, and we want to know how many of those it will take to get to 10. So 10 divided by 0.4 gives us 25. Or if you wanted to do that in, that's not 0.4 metres, that's 0.4 kilometres. Right, or the other way we could do it is to work in metres, and we'd have 10,000 metres divided by 400 metres, and that would also give us 25 laps. It's worth putting that word laps in because it makes it clear to the reader what you're talking about. Always try and answer in context. Right, number 13, if a measurement is 45 hectares, which of the following things are we measuring? Well, a hectare measures area, and a hectare, remember, is the unit that looks like this. It's got 100 meters going this way, and it's got 100 meters going this way. So if you imagine 100 lines that way and 100 lines that way. So that tells me that 1 hectare is equal to 100 times 100 meters squared, which is 10,000 meters squared. So if you need to convert between hectares and meters squared, you can do that. I actually find it always better when I'm doing hectare conversions to go back to this. Now, I made a video on 2 years ago for my Year 9 class on finding land areas with hectares. So if you want a little bit more practice at some harder ones on that, go and look in, go and search on the channel for hectares. Okay, I think the video is called Land Area and Hectares. Right, number 14, the area of a rectangle is 60 meters squared and the length is 10 meters. Right, always good to draw a quick diagram. So the area is 60 meters squared, and we know that one of the sides is 10 meters. So what's the other one? So 60 divided by 10 is equal to 6 meters, and that's the width. Right, so if you look at what I'm doing there with a tiny bit of algebra, because I can't help it, this is 60 is my area, and 60 is equal to base times height. So 60 is equal to, or we could say length times width. 60 is equal to 10L, and this is my equation. I'm going to divide both sides by 10. So again, we get L is equal to 60 divided by 10, which is 6. Now, when we're doing problems with rectangles that are this straightforward, we don't need to use that algebra. It's fine just to do that calculation. But as we get more complicated and we move towards the kind of measurement things we're going to do in level 1 NCEA, we're going to be doing a lot of work where we start with a formula and we substitute in for what we know, and then do some algebra to figure out the missing lengths or widths. Right, 2 more questions to go. Calculate the areas of these 2 figures. So this first one is a trapezium. And here's how I find the area of a trapezium. I look for my 2 parallel sides and I average them. Right, so that's A plus B divided by 2. And then I times them by the height. And the height here is the perpendicular height. So in this case, that gives me 5 plus 8 divided by 2 times 4. So that works out to be 13 over 2, which is 6.5 times 4, which is, I think, 26 meters squared. Right, so that's my way. I just want to show you how it looks on the formula sheet because it looks a bit different. It's the same thing, but I don't think it shows you the meaning as well. So the formula sheet back here on the front page, where is it? Where's the trapezium? Okay, here's the trapezium one here, and it's got, instead of putting the divided by 2 with the A plus B, right, which is where I think about it, it puts it in with the height. Now, it doesn't make any difference to our answer. I'm going to do it that way. H over 2 times A plus B. The H over 2 is 2, so it's 2 times 5 plus 8, which is 2 times 13, which is 26. But the reason I like this way more, even though they give you the same answer, is that in here you can link this thing to what you see up in the picture. And for me, I really like being able to do that when I'm doing measurement problems. I want to see how the algebra fits together with the shape that we're working with. Okay, right, the next one is this funny looking series of rectangles. So let's give myself some room here. This is what we call a compound shape. There are lots of ways to do these, but the best way is to divide it up and label the bits that you want. Now, I've just got 1 minute to do this one. The answer works out to be this, 438 centimeters squared, but I'm going to do it like this. I'm going to divide it into 3 rectangles, and I'm going to call them 1, 2, and 3. So area 1 is equal to 9 times, this bit is 8, this bit is 7, and this bit is 10. So 8 plus 7 plus 10, what does that give me? I'm really running out of time now. I have to finish this in the next video. Okay, stay tuned for part 3, and I will pick up this compound area problem in there, and we'll move into the relational questions as well. Thanks for your patience. Thanks for watching. I'm sure this is a little bit boring, but it's really good practice.